Welcome, class. Today we're going to deal with the mole, and it's not a furry little fuzzy creature like you may have heard of or something that's on your face, but rather it is a measurement that we use in chemistry that was discovered by a guy named Avogadro, and this is going to be very important as we move through the rest of chemistry. To some degree, it'll ultimately play into what I like to call kind of recipes for chemical reactions. And so we will use this extensively, so it's key that you understand the basics of what it is. So we are on Chapter 9A, the mole here, and this is kind of just the first part of Chapter 9. And let's first start by kind of defining what a mole is. It is a measurement, so understand that. In particular, it is a unit that we have, and that unit it says right there, it's the amount of substance contained in 6.022 times 10 to the 23rd particles. You will need to know that number, memorize that number. And if you look at that, that's a very large number. If you were to write it out, with move that decimal place 23 times, you'd have lots of zeros. It'd be a massive number, far more than we can comprehend, much, much larger than a trillion. And even a trillion is very difficult to comprehend. So really the question is, why do we use this? This is sometimes referred to as Avogadro's number. And the reason we use this is because atoms are so incredibly tiny, it takes a tremendous amount of them to really add up to anything. We don't measure atoms individually. If we do a lab, I don't say go and get 3 atoms of carbon. What I ask for is we measure things in grams, and in those grams, 2 grams or 5 grams or 10 grams of something, there are trillions and trillions and actually more than that of atoms. And so we have to use a tremendous amount of atoms to even equal something that we can measure. So that's what this number helps us to do. You could equate it. It is a unit that would be similar to, if I said a dozen, you would all know how many are in that. And we measure certain things in dozens, like eggs, we measure in dozens. Donuts, we measure in dozens. Okay, those kind of thing. Paper, we measure in reams. A ream of paper, and you may not be as familiar with this, those little packets of paper that are called a ream of paper, that's 500 sheets, okay, in there. That's a measurement there. And that's exactly what Avogadro's number is. It's a measurement, but we only use it with atoms and molecules, things that are incredibly tiny, because if we use it with anything larger, it would just be massive. And we may use some illustrations in class to kind of illustrate that. So let's get started here with kind of a couple different ideas here. We'll start with molar mass. Molar mass is actually fairly simple. It is the mass of 1 mole of a substance. In other words, if I had 6.022 times 10 to the 23rd atoms of something, what would its mass be? And it's actually really easy. Okay. They give an example here. A hydrogen atom, its mass, its atomic mass is 1, and we call that 1 AMU. That's what that symbol there stands for, atomic mass unit. And we don't measure things in atomic mass units because nobody would understand really what they are. In real world situations, it's an incredibly, incredibly tiny unit because it's the mass of 1 atom, 1 proton basically, which is meaningless to us. What is meaningful to us is if I have, instead of 1 atom, I have 6.022 times 10 to the 23rd. Well, conveniently, that means that I have 1 gram. And you'll notice there's kind of a correlation there, that 1 hydrogen atom equals 1 AMU. But if I have Avogadro's number, 6.022 times 10 to the 23rd atoms, I have 1 gram. You notice it's the same mass there, just different units, depending whether I have 1 atom or Avogadro's number. Well, which one is more practical to actually measure out in a lab or to use? Well, grams. And so that's why we use Avogadro's number. And where could I find all that information? I could find it on the periodic table. So let's do another quick example here. So carbon 12, which is the most common kind of carbon, its atomic mass is 12 AMUs, because it has 6 protons and 6 neutrons, and so the mass there is 12 AMUs of one atom of carbon. But again, that's not practical to measure out. But if I had 6.022 times 10 to the 23rd carbon atoms, then that would equal 12 grams. I can measure out grams. That is practical. That is a lot easier, and actually it would be 12.01, would be a little bit more accurate. And if you look on your periodic table, so it might be handy to have your periodic table out, you would notice that the atomic mass of carbon, that little red number that they have on there on your periodic tables, is also 12.01. Well, so now what that means is this: I can use my periodic table and I can look on any element and I could find what the 1 mole of that substance would be. Okay, so if I had 1 mole, or 6.022 times 10 to the 23rd atoms, I could look at any element and tell you what it's going to be. So if I look at oxygen, oxygen's going to be 16. Okay, how do I know that? Well, I look on there on the periodic table, and it's like 15.999 is its atomic mass. And so what does that mean? Well, if I have 6.022 times 10 to the 23rd, that means I have 16 grams of that. And so that makes it very easy. All I have to do is go straight to the periodic table, and if I have 1 mole of that substance, then that's exactly how many grams I would have. And it makes it very easy to measure it out. And we call that molar mass, the molar mass of an atom, or excuse me, of a particular, of a particular atom. And that means in 1 mole, what's the mass in grams, is what we're talking about. And so we're going to use that to kind of do some conversions here. And this is just an illustration, a chart. If you want to copy this down, that's great. Basically, it's just illustrating what I can do or where I can go with some of this. So all they're saying is if I start out in mass, and mass is always referring to grams, so make sure you make a note of that, I can convert mass into moles, okay, because there's a direct relationship between them. I can also, if I'm starting out with my number of particles here, okay, so if that's what I have is my number of particles, so let's say I have 7.2 times 10 to the 24th atoms, okay, of iron. How many moles is that? So I can also convert, okay, into moles from my number of particles. And I can also do the opposite as well. I can go from moles into number of particles, or I can go from moles into grams. And this is going to become very handy to kind of go back and forth between these. And I'm going to show you kind of how we do that here in just a second. So we're going to go ahead and continue on. Oops, I didn't want to do that. All right, let's try that again. And so here's a sample problem, and this is a lot of what you'll see on the test ultimately, or the quiz, is, what is the mass of 5 moles of potassium atoms? Now we know what 1 mole is because all I would have to do is go and look on the chart. But what if I have more than 1 mole? Such as in this case, 5 moles. So here's how you would set that up. We're going to kind of go back to the beginning of the year, and in the beginning of the year, if you remember, we did a little bit with the metric system, and we dealt with what we called unit analysis. We're going to kind of do the same thing here. Now currently, what I have is 5 moles of potassium. Okay, I want to get it out of moles, and it's asking me for mass. So that means I want to convert my moles into grams. So this is going to be a conversion. Anytime I do a conversion, hey, I'm going to set up a fraction. So you notice they're multiplying by a fraction here. And what they do here, so let's highlight some things here. Over here, this 39.10 grams, okay. Actually, excuse me, first what they do is they put moles here on the bottom, okay. Why did they put moles on the bottom? Because over here we had moles, and we want to cancel out our units. We always deal with our units first. Before I put any numbers in, I want to deal with my units first. So I want to go ahead and cancel out my units. So we have our moles there. I put moles on the bottom over here because it's up top on the other side. So that allows them to cancel out. And so if you'll look here, they're going to go ahead and cancel out. And then up top here, I have this 39.10 grams. Well, where did that come from? Well, down here on the bottom, I have 1 mole. This value is always going to be 1. Wherever the moles are, I'll always have 1. Moles are always 1 when I'm converting. So I have 5 moles here, and I'm converting. Put moles on the bottom. Why? So that my units cancel out. Moles are always 1. And then the question is, in 1 mole of potassium, how many grams are there? Where did I get this number? I went to the periodic table because, as we just said, what's the molar mass of potassium? Well, if I have 6.022 times 10 to the 23rd atoms of potassium, it will equal that value, the atomic weight, in grams from the periodic table. And so I go to the periodic table. What is it? It's 39.1 grams. That's that number in red. So if you're looking at your periodic table, you'll notice it's the same exact value. And then I can go ahead and do my math from there. And the math from here should be relatively simple. Okay, and so I end up with 196 grams. Now that's a rounded off number. I would want you to go ahead and carry it out to further decimal places. Let's do another problem. Now this problem is a little bit different. They're asking you how many copper atoms are in a 4-gram sample of pure copper wire. So this is actually going to involve 2 steps because you'll notice we're going from atoms all the way to grams. Well, there's no direct connection between atoms or number of particles and grams. But they do have something in common, and that is I can go from atoms to moles, and I can go from grams to moles. And so here's how we're going to go about this. First of all, I'm going to write down what I'm starting with. I'm starting with 4 grams of copper. Now I can convert grams into moles. And how am I going to do that? I'm going to put grams on the bottom. Why? Because that's the unit that I'm in. Notice they cancel out. That's the first thing I do. I don't put numbers first. I put my units. And then I'm going to put my mole up on top. Why? Because I put grams on bottom so that they would cancel out. So moles is going to go up top. And then I can go ahead and put my values in. Moles are always 1 in the conversion. And then where do I get this number here? The 63, this number right here, the 63.55. I got that number from the periodic table. Okay, in 1 mole, how many grams of copper are there? I go to the periodic table and I look it up. It's 63.55. And then I go ahead and do my math. And if I did my math, I would end up with 0.0629. Don't round off at this stage in the game because you still have 1 more step. You'll notice at this stage in the game, we're only in moles. Our answer is in moles. We converted to moles. The question asked how many atoms. So I'm not where I want to be yet. Okay. So I'm up to this point. So now I need to convert from moles into atoms. Well, how do I do that? Well, I'm going to go ahead and do the same thing. I'm going to multiply by a fraction, except this time I'm going to put moles on the bottom. Why? So they cancel out. Get rid of my units first. And then you'll notice I'm going to put atoms up top here, atoms of copper up top here. So then I have this little situation. Moles is always 1. So I put a 1 for moles. And then you'll notice in 1 mole, how many atoms are there? Well, that's Avogadro's number. Okay, that does not come off the periodic table. What comes off the periodic table is grams or mass. When I'm talking about number of particles, so atoms or molecules, that is always going to be Avogadro's number, which in this case is 6.022 times 10 to the 23rd. And then I can do my math. And so I go ahead and do my math, and this would be the answer. And so now my answer is complete. And that's how you use moles to make conversions from grams into moles or to find number of atoms in things that will be somewhat practical. And we'll do some more practice with this in class.